All right, section 3.2. Recall the notation we use for composing functions. So what I want you to do right now is I'm going to do this example, and if it doesn't make sense to you, I want you to immediately stop and Google composing functions or composition of functions, because the rest of this video will make absolutely no sense if you don't understand this algebra thing. You're also welcome to send me an email and say, I don't get it, and I'll help you find the videos. But I'm betting some people do recognize this. So if I've got this function f of x and this function g of x, when I compose them, f of g of x, this notation means that in the function f of x, everywhere that I see an x, I'm going to replace it with g of x. So my function is 3 times x minus 1 divided by x plus 2. And everywhere there was an x, I'm going to replace it with g of x. Okay, but g of x, I know, is actually the square root of x. So this would be 3 square root of x minus 1 over square root of x plus 2. So that's my final answer. Okay, now g of f of x means I take the function g, and everywhere I see an x, I replace it with f of x. So g is the square root of something, and everywhere it's, the square root of x, everywhere I see an x, I replace it with f of x. So the square root of f of x would be 3x minus 1 over x plus 2. So notice that these two, f of g of x and g of f of x, they're not the same thing. They're different. That is important. So what we're going to deal with in this section is what happens when we have a composition of functions and we want to take a derivative. So for number 1, I have 3t cubed minus 2t plus 1, and all of that is to the 5th power. So now I want to think about it as a composition of functions. And the function f is my outside function, and that is whatever it is on the inside to the 5th power. So I'll just think of it as x to the 5th. And then the function on the inside is this 3t cubed minus 2t plus 1. So the chain rule says if you have a function, f of x, and it's made up of a composition of two functions, then to take the derivative, you would do the derivative of the outside and then plug the inside in, then take all of that and multiply it by the derivative of the inside. So this actually might look a little bit familiar. This is like our chain rule. The rule we were used for it's called the generalized power rule. The generalized power rule is very similar. This one is just stronger. It's like sort of like that. So again, this is something to put on a note card. It would be great if you had it memorized, but not everybody's brain is all into memorization, so just write it on your note card. Okay, for number 2, it's like our first example of really using the chain rule. Use the chain rule to differentiate y equals f of g of x, where f of x equals the 4th root of x cubed, and g of x equals 4x to the 6th minus 6x squared minus x. Okay, so in order to take this derivative, y prime, from what I've learned here, it's going to be the derivative, and this is sort of evil actually. So y equals f of g of x is what I'm given, but here f of x equals g of h of x. So there's a lot of, we have to think about which thing actually represents which thing. So let's start with y, let's write out what we started with. Y equals f of g of x. So f is outside, g is inside. Oh, it's about to put like inside. Okay, so when I take the derivative, according to my rule that I just learned, it's going to be the derivative of the outside, and then I plug the inside back in, and then multiply by the derivative of the inside. Okay, sounds good so far. So they gave me what f of x was, and they gave me what g of x is. So I'm going to need the derivative of f of x, f prime of x. And that would actually be easier if we rewrote this. So I've got x to the third, and then it's fourth rooted, which is the same thing as x to the 3 over 4. So when I take a derivative of that, that's going to be 3/4 x, and then 3/4 minus 1 is minus 1/4. And then I also need g prime of x. So just the power rule here, bring down the 6, that's 24x cubed, minus 12x minus 1. Now I'm going to do my composition of functions. So y prime, I need f prime, but everywhere there's an x, I'm going to replace it with that g of x, which is the original thing up here. Okay, so f prime says 3/4, whatever x is, raised to the negative 1/4. And I'm supposed to plug in g. G is 4x to the 6th minus 6x squared minus x. And then I'm supposed to multiply by the derivative of that inside function. And I found that already. That's 24x cubed minus 12x minus 1. I don't need to simplify. Let's do another one because this is a little iffy. Okay, so I'm supposed to use the chain rule to differentiate this, and my outside function is f, and they also give me what f is more explicitly. Okay, but to do the derivative, h prime of x is going to be the derivative of this outside function, and then I plug my inside function back in, and then multiply by the derivative of the inside. So just like a little tip, I don't know if this helps anybody else, but this is not the way that I like to have the chain rule written. So these notes are a friend of mine, not my own. If I was going to write the chain rule, the way I would do it is, let's say y equals an outside function and an inside function. And I go to take a derivative. That is going to be the derivative of the outside. Plug the inside back in, and then multiply by the derivative of the inside. That's how I write it. I'm sure that's worse for some people, better for others, but that's how I would write it. So this isn't so bad. And I forgot to put the derivative symbol, right? Because I need the derivative of the outside with the inside plugged back in, and then multiplied by the derivative of the inside. Okay, so, oh, and f of x, this is like what we had before. This is the same thing as x to the 3 over 4. So f prime of x, which we're going to need, right, if we're going to do this, is 3/4 x to the negative 1/4. Like 3/4 minus 1 is minus 1/4. Okay, so I need h prime. And h prime is going to be f prime with this part plugged into it. So 3/4 x to the negative 1/4. And I'm going to plug in 2x cubed minus 20. And then I'm supposed to do the derivative of this here. So that would be 6x squared. Derivative of negative 20 is just 0. And I'm done. Okay, let's just keep trucking along. Number 4, and I'll keep my my formula up here in the screen as long as possible. So I'm supposed to use the chain rule, but this time I need to figure out what is composed with what. So if this is something you have trouble with, you really please do go and review composition of functions, because it relies heavily on you having a pretty good understanding of that. So I'm looking at this and I see the two functions, h of t equals something to the 5th power, so that's one function, and then on the inside 3t to the 4th minus the cube root of 2t plus 1. So I think my outside function, oh, and I should write O of x. The eraser's gone missing. Okay, no eraser today. So the outside function, I believe, is x to the 5th, and the derivative of that would be 5x to the 4th. And then my inside function, I of x, that's the inside bit, 3t to the 4th minus the cube root of 2t plus 1. And then I'm going to rewrite this so that it's easier to take a derivative. 3t to the 4th minus 2t plus 1 to the 1/3 power. Now I'm rewriting it that way so that when I take the derivative, it's a little bit easier. So the derivative would be 3 times 4 is 12t cubed. And then my generalized power rule, I get 1/3 times 2t plus 1. 1/3 minus 1 is minus 2/3. And then I'm multiplying by the derivative of the inside, which is just 2. Okay, now I've got h of x. To figure out what h prime is, that's going to be the derivative of the outside with the inside plugged back in times the derivative of the inside. So now it's just plugging in what I've got. The derivative of the outside is 5 times I of x to the 4th. I of x, let's see, is 3t to the 4th minus the cube root of 2t plus 1. Okay, so I've got the derivative of the outside, I plugged the inside in. Now I'm going to multiply by the derivative of the inside, which is 12t cubed minus 1/3 2t plus 1 to the negative 2/3 power times 2. No simplification necessary. Let's call that good for now. If you have questions, please do ask them on the discussion board.